Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
All right. The last talk from the Search RFP winners here will be given by Brian.
Okay. Last talk, almost the last talk. So, something maybe you haven't been thinking about, but we'll get you there. I want to talk about a war that's going on. And it's not the usual suspects, not in Afghanistan, and maybe you know where I'm going. Not in Iraq, not the war against drugs. It's the war between search engines and spammers. And for the hearts and minds, yes, of what the search engines are going to believe. And maybe you've noticed this. A few people have mentioned this. So here's an example just to get you going. So here's a not unreasonable query to a not unreasonable search engine. So for a particular drug and asking about some information about it. And if you look through, maybe you can see some stuff in there that looks a little funky even without looking at the pages. In fact, link number 5, not really a good page, and certainly there because of some spamming techniques. Number 6, number 7, number 10. So 4 out of 10 from this particular search engine. Now, to be fair, I have to do the same thing with live. And here we've got number 2 and number 3, nicely looking sites, but link spam nonetheless if you dig a little bit. Number 5. And I guess that was it for that one. I've got other ones too, but this is just to give you an example of a reasonable query and something that gives unreasonable results because of this war that's going on. Of course, this hasn't been unnoticed, and search engines are indeed working to fight this effect, fight the attacks that have been made by search engine spammers. And so one of the most prominent ones, most visible ones, was a year and a half ago, I think in 2005, where Google recognized and decided to do something about some what it considered to be some spamming efforts by the German web page for BMW. So this is the text that a search engine would see from BMW. And this is the page that a user would see. Something really quite different. And it ended up being some redirection involved. And it was enough to get them delisted or blacklisted. And lo and behold, they changed and they got fixed. And it was a nicely highly visible event. And in fact, this is something that not only the search engine is paying attention to, but researchers outside the search engines in the labs and in academia. And that's where I come in. So my talk is about incorporating trust into recognizing, into calculating web authority. And this is work with my students, Lan Ni, Xiaoguang Qi, who's back here, and a student who just graduated, Baoning Wu. So really this wasn't always the case. 10 years ago, the web did not look like this. It was content that was created by amateurs, by hobbyists, by educators, and not so much by commercial interests. But today, that's not the case. And so now we really do have a battleground. And as a result, web spam accounts for a significant fraction of the pages on the web, a noticeable fraction. And it varies depending on who you ask. So what is search engine spam? I'm not going to go into detail, but I'll just mention a few things. Anything that's going to adversely affect the ranking from an objective point of view. So if you're trying to manipulate the search engine in getting a result that's higher than what your page deserves, that's what some people are going to call search engine spam. And this includes things like keyword stuffing, it includes link spam, it includes link farms, comment spam, cloaking, lots of different things. And why do they do this? Well, to make money. That's almost always the reason. So really, it's the opportunity to display advertising. That's one of the biggest reasons. But they can also try and sell you something, although that's perhaps a little bit harder considering you didn't want to be there in the first place. But in any case, they'll get to give you some kind of message and present their message that you have to see it at least, then you can back out. And this is important not just for the search engines themselves, but to the searchers. It reduces the quality of results that they see. They can get confused. They can even see content that's entirely inappropriate. I mean, by inappropriate, I mean anything from just off-topic to offensive. And it certainly affects people who are trying to analyze the web, such as blog analysts that are trying to see what the trends are. And is this new trend that they've discovered, is it something that's truly a trend? Or is it something that has been created by someone trying to create a new message that is visible because they're trying to make their sites more appealing to searches? It's a problem for search engine providers, to content providers. Why is this? Well, you might think that they're not affected. It's just the engines that are affected. But they get ranked too. And when a spammer moves to the top, that means somebody else had to move down. And so you have an effect where people are trying to decide, well, if I'm going to keep my page ranked highly so I can have the livelihood that I get from being ranked high, do I need to compete in the same way that my competitors are succeeding? It also affects blogs and discussion boards where you've got comment spam that gets added. And you also have victims of plagiarism where you have great content. You spent a lot of money, a lot of time just to see it lifted, placed on somebody else's page so that they can be ranked highly and perhaps displace yours. Search engine providers, of course, are concerned about this. The reduction in quality, effort, resources for crawling, for storage, for analysis. And they have to keep changing their algorithms because the approaches change, and so that means that they have to keep working on better and better approaches. So I'll note here that we can't ignore some of the things that are being manipulated. So the main focus for this talk is on link spam and what we might, one particular way we might get around it. We can't just ignore the links. Links are important for being able to do web search well. There are just too many relevant pages for so many queries. We have to have some way of distinguishing between not just relevant pages, but quality pages or important pages and be able to bring them to the top. Anchor text, too, is essential for some kinds of pages. And so analysis of the links really determines how important the sites are, but this still leaves us, and this is the problem, it leaves us vulnerable to link spam attacks. So what if we knew or could estimate which pages were trustworthy? And which pages had content that we were going to trust for Amelie, or which pages are going to have content or have links that we can trust, for the work that I'm going to talk about. You might ask people to give their opinions. You might look at the whitelist and blacklist that search engines already have for spam and for non-spam. You might be able to take that and estimate trustworthiness for others, and that's there are some ways of doing that, and I'll mention them in a minute. So the thesis that we're working under then is that trust and distrust information, sort of the opposite, it can inform web link analysis, and we're going to talk about how you can do that. Okay, so how are we going to do this? Well, if you talk about PageRank, and in fact all the other standard web link analysis approaches consider every link to be valuable. They're all equally useful. We're going to count them all because we don't know, we haven't considered whether they're not being useful or not trustworthy, to use the word. And so some of them aren't. Some of them are spam. Some of them are phishing pages and so on. So the question then is, can we improve PageRank if we know or can estimate the trustworthiness of pages? And of course, the answer is that we want to give you is yes. So the approach that we have is to provide a cautious surfer. So PageRank, as you know, uses a random surfer. We're going to use a cautious surfer that's going to look at the trustworthiness and have that affect how that surfer operates through the web. So that trust will be used as hints to affect the behavior, and it will then emphasize the links that are present from trusted pages or trustworthy pages, and de-emphasize the links, the targets of links from untrustworthy pages. And for the purpose of this, I'm going to say that we can use anybody's trust estimate. So if you have a particular favorite way of doing trust estimates, fine, you can plug that into this approach. We're not arguing for a particular one in this. But there are some sources of trust that already exist that we can use. So one of them, and probably the most The first one is called Trust Rank by John G. and colleagues. They pointed out that good sites tend to point to good sites. It's a reasonable observation. And so we can now take a set of good sites, call them the seed set, and do a personalized page rank based on that seed set. So that every time we do a random jump, we're going to randomly jump back to the seed set, and we find out which pages are trusted by that seed set in effect. And so we now have a way of ranking the web, or whatever the collection you have, based on how trustworthy, or how, in effect, how close you are to a trustworthy page. Another variation a couple years later called Spam Mask from the same group takes Trust Rank and does a slight variation where they calculate the fraction of the page's page rank that is due to spam, or what they propose to being due to spam. So in the bottom right, you can see that we're considering that Spam Mask asks, here's the page rank score, here's the trust rank score, and the difference has to be what was not trusted. So the assumption is that that's the spam contribution. Other variations are to take some of the spam work that's been done that has used propagation in the reverse form, to use that as a trust source of information. So propagating spam estimates backwards, and that's been done by a number of people. And in general, the observation is that if you've got a bad site, a spam site, or untrustworthy site, people who link to that site, who trust that site, are also therefore untrustworthy. So we can propagate backwards in some form, and that's what these approaches take. Last variation that we could consider using, although we haven't done it for this work, is to consider the idea of web decay. A few years ago, Baryasov and Broder and colleagues talked about considering pages that linked to pages that were no longer there anymore, 404 errors and so on. And obviously such pages haven't been updated. The authors haven't checked to see that their links are still good. And so there is some decay going on. The links aren't any good. Perhaps there's other content on those pages that are also out of date or not appropriate anymore. And so they proposed a propagation in the reverse graph in the same way. A final version is some work that we've been looking at in an alternative trust propagation method, which instead of propagating in a form like PageRank, which conserves the trust or the rank information as it goes through, we consider variations that allow you to pass trust without concern, say, for the number of children that you have, or a version that doesn't concern itself with just summing the trust that you get from your parents, but maybe just taking the maximum one. So other variations, alternative variations, and so we can consider those as well. And these are just different sources of trust information that we can then integrate into a PageRank or other link analysis approach. And in this work, we've also considered combining trust information as well as distrust information in a very simple way of looking at the difference, or weighted difference. So then how do we incorporate trust into web search? Well, we're going to recognize, first of all, that the trust-based methods can't be used directly, or at least we argue that they perhaps shouldn't be used directly, because trust isn't the same as authority. And in fact, the trust ranks, for example, pages that are not near the seed sets are out of luck. They are automatically considered to be spam or of little value, and it doesn't matter whether they're spam or not. They're marked as such, or they're at least demoted as such. And in general, selecting and labeling a large seed set really is not feasible for the web. So how to utilize this trust then, it has been the open question. And for us, we're going to show how we can do it by modifying PageRank. So PageRank has three different ways, three different choice points at which we can sort of affect how decisions are made without totally changing the algorithm. So the first is just instead of giving a static probability of choosing a link to follow versus randomly jumping, we can now do that dynamically, or not dynamically, but on a per node basis, a per page basis. And so that's the first equation, where we now, instead of having a small d that's 0.85, we now have a function d of the node I. A second variation is to decide with some more is to take the choice of where to jump instead of just jumping with a even probability to all pages. We can now decide as personalized PageRank does and as TrustRank does, to go to a certain seed set or, in general, to some arbitrary distribution. Third version is which link to follow. So if you're going to follow links from your page, you can now say, I'm going to follow this link with higher probability than this link as a function of that node or a function of the nodes that you're going to link to. So in our cautious surfer, we're primarily interested in the choice of whether to follow or to jump. Because this is where we can now, instead of doing this as a static probability, we can say, let's do this on the basis of the trust information or the trustworthiness estimate that we have for this page. And we also experimentally see some benefit in biasing the random jump vector as well. Okay, so just to make this really clear, we'll walk through a very simple example. So here we've got 10 nodes, colored red and yellow. If you can see it in the back, 3 of the yellow nodes have thumbs up signs. Those are the trusted ones. Those are the ones that we know are trusted. The other yellow ones we don't know. The red ones we're going to say are spammers. They've got a little link farm there with everybody cross-linking to each other. So some of these pages are trustworthy. They're the thumbs up ones. Some of them are untrustworthy. These are the red ones. And some of them we don't know. We don't know how good they are. We don't know whether they're trustworthy or not. Those are the other yellow ones. And the question then is, which ones of these should be ranked highly? And so if we look how the different algorithms treat this problem, it helps cement the way this algorithm is working. So with PageRank, it's pretty straightforward. You should have seen it by now. Here's what PageRank generates in the end. That link farm ends up dominating the PageRank calculations, and so it gets the highest score. So at the very bottom, I've got from left to right the most highly ranked page to the least highly ranked page and the scores associated with them. And I've tried to color them sort of in intensity in the same way on the graph. In TrustRank, we're now going to be randomly jumping not to any page at all, but to the seed set. Now, 3 out of 10 is a large seed set, so let's just, for simplicity, we'll just choose one of them. We'll make number 9 our seed page and see how things operate from there. And again, pages that aren't near the seed sets end up being considered untrustworthy. So what does TrustRank do with this? It gives a result that says that, well, the pages near the seed set are highly ranked. So the seed set itself, the seed page itself, that's the best one. And the ones that you can see flow some trust downstream in the usual way. And then we've got half of this web is unscored at all. It's got a zero score, and so they're all equally bad in TrustRank's eyes. Cautious Surfer, the one that's combining these two, is going to emphasize the ones that are trustworthy, emphasize the links that come from trustworthy ones, but they're also going to still allow the regular PageRank mechanisms to provide some contribution. And so with this one, we find that node 6 ends up being the most highly ranked one. And so we get the same benefit, we get the nice benefit of pushing down the nodes that are untrustworthy, the ones that are doing the link farms, the ones that are very, very far away from the trustworthy ones, but we no longer have to emphasize the trusted set either. So it's a nice compromise.
Big question.
Yes?
How do the for now since the link farm? How do the trust level?
For number 5?
From 1 to 4.
So 1 to 4 is the link farm that we identified before. Number 5, we have no information, not for either algorithm, so it ends up being ranked poorly. So no.
Trust level will be 0 in this problem.
I'm sorry?
Trust level will be 0 in this problem. 0, 5.
The ranking score will be 0, or very close to 0, as you can see, for number 5. It's not 0 because there is the random jump that will go to all pages. So there is some contribution that's given to every page through the random jump. Yeah. Okay. So we've also done some experiments to evaluate how well this approach works. We looked at 2 data sets, UK 2006 data set. The nice thing about this one is that it's got labels, and we'll talk about that in a minute. And we also looked at a larger data set from Stanford WebBase, which actually has very little spam, so it's a different kind of data set to consider. And then we're going to look at some baselines and TrustRank and PageRank and our approach and so on. So the data set, the UK data set, was created as a crawl of the UK web. It's a small crawl, but it has been labeled. Many thousands of hosts in that site have been labeled with spam, non-spam, can't can't tell, the undecided, or haven't been labeled as unknown. And we took 10,000 popular queries. It doesn't really matter from where. In this case, it was not this particular set, but it didn't really matter. And we looked for ones that, the 10,000 most popular, that also had at least 20 pages that, in our data set that we could work with. And we're now going to use the labels as a proxy for quality and ask what's the distribution of those labels on the top results from these queries. So here are the distributions, the cumulative distributions of, on the top left, of spam pages, a fraction of spam pages, and the bottom right of normal pages, asking what fraction of queries had at least n spam pages. So if we look over here, this is for the top 50. If we look here, we find that BM2500, our baseline text, just plain text retrieval, had at least five spam pages in about 85% of the queries. So it's a way of measuring how well the different algorithms put spam at the top and how well they can remove spam from the top. So there's spam here. We can see that the textual analysis one does the worst with respect to spam pages. Page ranks in the middle, and the one that's based on trust rank directly, and one that uses our cautious surfer, both do about the same in reducing the amount of spam. And likewise, they both do the best in bringing up the good pages, and the others do not as well. And so here, if we just ask overall, what's the distribution look like? And so here are the 4 categories that we saw originally, and what the top, in this case, the top 50 results. And you can see that, indeed, we've got lots more good pages. We've got significant reductions in spam pages, and it turns out reduction of the unknown pages as well. Okay, so second approach. So that was really, are we at least doing as well as we'd like with respect to spam? Now we really want to know, is the quality also staying up? So here we're asking real people as to what the quality of the results are. Is this relevant? Is it not relevant? And looking at top 10 results over that. So we've got about 30 queries in each of the data sets. We have a seed set in the first case that we take 10% of the labeled data, and we take intersection of DMOZ pages, highly trustworthy pages, or at least good pages in some sense, the intersection of those with web-based to get about 0.17% of the pages, and then evaluate them with a precision and a score, since we've got better than just binary relevance to look at. Okay, so we're almost done. We're going through, and here I just want to point out that yes, indeed, this purple, bluish purple, is our cautious surfer, and it outperforms all the others. It turns out this is statistically significant over all the others, except for, which case is it? I think it was this one. It's one of these two. The others are all statistically significant. And then on web-based, we also see the same trend. Sorry, it's not in the same ordering. Just comparing PageRank, TrustRank, and Cautious Surfer, again, showing that on average over these 30 queries, we can show a decent improvement. So in conclusion, we've proposed a different kind of surfer, a cautious surfer for the web, one that integrates trust estimates into PageRank and combine both trust and distrust, although they didn't talk much about that here. Can perform much better than PageRank, and it will also perform better than using the trust-based methods directly. I want to say a couple of things about ACID usage. I have another project on analysis of query logs, and for that we've found that having access to the query log is quite useful. And for this, we're interested in understanding the topical distribution, the topics of interest of searchers represented by a particular log. And so we took the results, took the queries, looked at the top 50 results, classified each of those snippets across ODP categories with an naive-based classifier, and got a distribution of topics, distribution across topics for every query. And this is really just getting started with this data set. We haven't gone as far as we want to. And I just want to show you a little bit of what we've gotten out of that. And so here we've got the distribution, sort of the background distribution then of the query data set. This all of the queries, or essentially all the queries. And we looked at different ways of weighting this, just by weighted frequency. So that's the blue one. That's sort of the normal way. Looked also just at the click-throughs and to see how much that would change the background distribution, and also if we average across sessions rather than averaging across individual queries. And yes, we see some variations in what are the most prominent categories showing up, but it's not a huge changes. We also looked at how often or how many topics were relevant per query, and you can see the distribution across topics. There's often more than one topic that's relevant to a query, but it's not. There's usually something that dominates. And overall, our evaluation or usefulness of the query sets, well, we like having such large data set. That's really a nice improvement over what we had in the past. Getting access to result sets, we did it sort of in a bumbling way in the beginning ourselves, and got result sets from Microsoft, which is great. We had some problems with the API, so that's one of the bad things. The fact that we needed to request result sets later on, as people have mentioned before, it has been a problem, and it's always nice to see exactly the results that the users saw when they issued the queries, so we can match up click-throughs and so on. We would have liked to have seen user identifiers, so we could average across users and say what are the topics of interest to the average user or cluster users, rather than having to cluster queries or sessions. And the one didn't fit on here, so I had to do a different slide. Yeah, so user IDs, geographic IDs would have been helpful, so we can say, well, people in North Dakota have different interests than the Bay Area, and so on. We would value getting access to the static rank for each page. We'd like to see what the distribution of the static ranks are across different queries and so on. So it would be helpful for that. Or just give us the web graph, and we'll calculate our own static scores. That would be fine too. And then the last one is really, you asked me what I wanted, and I'd really like to see user traffic, click-through traffic, not click-throughs of search results, but click streams, whole thing. I'd like to see what the click stream graph looks like, and not just the web graph. Yeah, exactly. So thank you very much.
Questions? It seems that spammers like to take an expired website that used to be a trustworthy website and then use it for
Absolutely.
spam.
Yes.
How would your algorithm react to a website that changed trust drastically, and how would that propagate?
So there's nothing in particular that we're doing to recognize that. But if you are a company that knows about all domain name registrations and can see domain name transfers, you have access to that information and could easily add that as a component into a trust score, a trust estimate. And so we would take advantage of it that way. But there's nothing in here specifically to look for that particular problem.
Wouldn't you have the risk of propagating mistrust to pages that link to a previously valid website, trustworthy website, but not anymore?
So it falls into the web decay type of idea. You're recognizing that the person who created the link to the old website hasn't updated their site, hasn't looked to make sure that everything's valid, and so you can say that this is now a less trustworthy page. Yeah.
We can take another question. Oh, just okay, a couple more.
So I don't know if this is a serious point, but would you like to classify nodes as being trustworthy otherwise, or would you like to classify links as being trustworthy otherwise? I mean, the problem cases in spam are always, sites which are sort of okay at large, like .edu sites, out of which there are some suspicious links.
Sure. So absolutely, the real interest would be to classify individual links. Yes. I think we can do that. That's perhaps a harder problem than recognizing when a page has untrustworthy content on it. But sometimes it's, as the reverse propagation approach that we mentioned earlier, you can see which links are causing problems, and that gives you questions about the remaining links. It doesn't really necessarily invalidate them, but we're assuming that it does. Yeah.
Maybe we should have some sort of distribution about co-cited links being probably corrupted because there's one bad guy.
Right, right. Well, that's effectively what we're seeing here, because we're taking a page and marking it as untrustworthy. So we're not following. We're less likely to follow its links. We'll still allow that page to be highly ranked. However, it can still be highly ranked and be untrustworthy at the same time. Good question. Yeah.
Yeah. So how robust is this if a link farm also links to a lot of good, trustworthy sites?
It's fine. The distrust is propagated backwards, so that part will affect the poor people who are pointing to a link farm. But anyone can point to good sites, and there's nothing. That doesn't hurt the good site at all. Yeah, there's nothing affecting it that way.
Thank you.
All right. Thank you.